Okay guys, so now we are looking at trigonometry. So I've just highlighted important things to remember. So you need to just know that sine squared theta or x plus cos squared theta equals to 1. And with that being said, sine theta plus cos theta is not equal to 1. It's only equal to 1 when it's a squared. If it's a 3 here, it's not equal to 1. If it's a 5, it's not equal to 1. Only when it's a squared. So you need to remember that, it's important. And from this, if we want to have only sine as a subject of the formula, we just transpose cos to the other side, and the same thing with cos. So these two guys are deducted from the first statement here. So that is very, very important. The other thing that is to be noted is that tan of theta equals to sine over cos. That one you know. And then sine of negative angle is negative sine theta. Tan of negative angle is negative tan theta. But a cos of negative angle is a positive cos. So if you want to not confuse yourself, just do this. Wherever you see negative angle, just say 360 minus theta. So you'll see that 360 minus theta falls in this quadrant and sine is negative. So that there is negative theta. So basically sine of negative angle, you can rewrite it as sine of 360 minus the theta. Then you will now see why is it negative. The same thing with tan of 360 minus theta. You'll see that you find negative tan theta. But if you say cos of 360 minus theta, you see that you have a positive cos theta, because in this quadrant cos is positive. Okay, so those are the things, the stuff that you need to remember, these three guys here. And then these ones here, you need to know that a sine of 90 minus, remember in a Cartesian plane this is 90. 90 minus takes us to the first quadrant where everything is positive, right? So 90 minus theta, because of 90 the sine changes into cos, and then also the cos changes into sine. But now when it's 90 plus, we are going into the other quadrant where only sine is positive. So now if I say sine of 90 plus theta, I am a sine and I am going into my space, my quadrant. So even though I become a cos here, I will become a positive cos because originally I am a sine. But if I am a cos and I am going into a sine space, because 90 plus theta goes into the sine space, but I'm from a cos, so I must become a negative sine. Even though I'm going to become a sine, it will be a negative sine because of I'm going into a space that is not mine, just because I'm originally a cos. So you need not to cram this. If you can just get them the way I explained, you are sorted. So now these are the directions that are acceptable to go into quadrants. It's advisable to use 180 and 360. 180 minus, that leaves us here. 180 plus, that leaves us here. 360 minus, 360 plus, yeah. So this is just the Cartesian plane that is acceptable. So okay, here what I was trying to show is that if you have a bigger angle like this, okay, so you can reduce it. And the only way to reduce the angle is to use 360. There is no way where you were taught 900 minus theta. So you say 900 minus 360, that's 540. It gives us 540. We've never seen 540 minus theta, so we reduce it again with 360, so it gives us 180. So this thing, we rewrite it as 180 minus theta, because the 900 minus 360 minus 360 again gives us 180. Then we know that cos of 180 minus theta gives us negative cos theta, because it goes into the sine quadrant. Negative 180 minus theta goes into the second quadrant. Yes. So we can use that information to, to solve problems such as these. Maybe we can do the first one, that's sine of x minus 180, and then we have 10 of x, we have cos of 690, which is a bigger angle also, we need to reduce it, cos squared x minus 90. Right, so to simplify this, you can see I taught people the method that I came up with of, just substituting x here, because this is a negative direction. 0 minus 90 minus 180 minus 270 and minus 360. Remember the normal Cartesian plane, this is 0, 90. But this Cartesian plane of negative direction, the 90 is here, it is never there. Okay, so you just substitute any angle here. Maybe we usually use 30, so you just say 30 minus 180. It's gonna give you minus 150. Minus 150 is in this quadrant. You can see is between 90 and 180. 150 will be in this quadrant in the negative direction. Okay, so, and in this quadrant only 10 is positive and I am a sine, so already I know this is a negative sine of x. I'm done with it. Then here it's a sine x over cos of x, and then cos of 690, I must reduce it. 690 minus 360, it is giving me 330, so it's gonna be cos of 330 over, now you can see this one is a cos squared. Anything that is a squared will end up being a positive, so I will write it as negative sine of, squared x, because the 90 turns this into a sine, right? So I will come now and say negative sine squared x over cos of x multiplied by cos of 360 minus 30, because 360 minus 30 is 330, over sine squared x. Okay, and therefore this is me simplifying this times this is what gave me sine squared x, and then over this cos, then that one is not on the side. So this is in the fourth quadrant and cos is positive. Negative sine squared of x over cos of x, and then that will be cos of 30 degrees divided by, or we can just say this is divided by sine squared x, so that we can just turn it around there, and this is going to be cos 30 is square root of 3 over 2, square root of 3 over 2, that's negative sine squared x over cos x multiplied by 1 over sine squared x. So these brothers will cancel, and then I'm left with negative square root of 3 over 2 cos of x. So this is the simplified version of that. Okay, so yeah, so that's basically how you do it and so forth. So this guy, you scratch him off, because we have the 2x, which is grade 12 concept. I took this problem from a grade 12 paper, right? And the general solution, this one, general solution, I taught this concept of general solution, but this one is with restriction. So yeah, I think we did this even. Yeah, so it ends here. Best of luck for tomorrow.